So let's add this as item fusion card that adds activation event to the item. Because what happens if I get rid of the only one item I get at the beginning that has an activation event of on combat? There. Maybe it's rare. What should I do? But the problem is that the rarity, you know, it's going to be rare. But on combat enter, on poison, there I could do a combat exit, for example. There, so that way I don't need a combo to activate it. On combat enter. So this should be really rare, because if it activates, it should activate others, right? Imagine if I have a card that says on combat exit, right? On combat exit, and then on combat exit. Wait, the song is really distracting me. The lyrics are distracting me. Okay, on combat exit. So there, better. So there. So I have this on combat exit, and it gets triggered, and it has a combo that will activate other cards. That can work. So I can do on hit, or yes, on combat, while on combat, because check this out. So this is the things I need. The activation trigger, activate while conditions, there. It activates while it's on close combat, in close combat. Activation item card. Their condition flags. Activate while. condition. In close combat, in range combat, sleeping, dead. That makes no sense. Dead. If it's dead, it does nothing. Let's change this. Poisoned. There. Poisoned. Poison. Poison. There, that makes more sense. Sleeping, poisoned. So while it's on close combat or range combat, that's an event. So maybe I should add, instead of making a new card type, item component with new activation trigger. On combat, enter. On poison. So how many effects do I have? Weak, shield, sleep. Effects, confuse. There. Stunned, frozen. Poison, weakened, confused. There, conditionings. So on combat enter, on combat exit while on combat. So the thing is, it's actually more complex because I need to set all three, because all of these three can be none. See, none, none, none. So are these flags? Card trigger is a flag? No. So if a card comes without all of these three guys, how can I configure all of these three? Well, I'm going to have some presets like I do on the component creator. Component creator there. So here I can configure each effect, create combo, and here I could have the events, the activation and deactivation events. These three. So I can predefine some that actually make sense. I can have one that says enter and exit combat, and for example it activates while I'm poisoned. Actually this doesn't make sense, because if I'm sleeping I can't do anything. Anyway, so I'm poisoned. Yes, that works. Weakened or confused. Alright, so that makes sense. So I could get predefined. Okay, I have that, and I could give you, the player, random cards that have these trigger events, and when you fusion it to a card, it gets added, just like the effects card or the combo card. But it should be very rare. It should be really rare. Right? Is this correct? Yeah, I think it could work. Yeah. 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 The default trigger events card should read like that. Should it say fusion it to an item card to apply this new card activation trigger. So it should say event on exit combat while poisoned, while confused, while on combat, on exit combat, while in combat, and so on. There. So that makes sense. Yes. Or should it say trigger, right? Trigger or event. Yeah, that makes sense. Yeah, that makes sense. Okay, so let's add a new type, other potion effects, combo effects, items, components. I have a combo, so this is a new one called trigger. Condition. I have this one here, trigger. Trigger for what? Let's be specific. Activation trigger. So I have this here. Let's see, combo, create new combo item component. Let's search for combo item component. So this is the example. There, I should copy this. And let's check effect. Effect, item component. Oh, look at this. I command that takes an entity being. I command that takes an entity being and a card prefab. Activate effect. Execute. There. So this has an execute. Alright. There, it takes this and that. Context and target. Okay. So this is called effect item component, combo item component, and this should be called activation trigger item component. Item component. Activation trigger item component. There. So let's see, activation trigger item component. So this one interface execute okay, I command. Oh, it's because these are different interfaces. Okay, let's see. So with this, I don't know, item component. Let's do this. I'm not sure what do I need. I command. So there, this executes entity being context. So let's see the combo. So actually this doesn't have an execute because it's passive. It's a passive one. Cache target, execute. Does it have two executes? No, only one. So there are two activate effect. Okay. Okay, so I have this here. I have the activation event. Execute. Maybe I shouldn't have this. let's change the goal. Add activation trigger card for card item component cards. There. Add activation trigger item component cards. There. So what does this do? What does this do? So let's add these guys. Create effect combo components and create combo components, and let's do a private create activation trigger activation triggers. Let's do like that, or let's do a void. There, data. What's this data? Base item component data. Okay, let's do a new one. Or let's not. Let's just void. Wait a second. So this is abstract, so I really need a new one. So activation trigger there. Dun, 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 dun. Then let's do this. Private list of these activation triggers, activation trigger components data list. There. So I have this guy here. Activation trigger. Activation triggers. Components. Indexes. Activation trigger components. Indexes shuffle back. There we go. So with this, I do a create, wait, let's do a new there. So let's create the thing I need here. This okay, let's create this guy. Let's do a private free activation trigger component data. Create new activation trigger data. So what do I need? how does this work? So there. So this is more similar to the combo. So let's place it. Let's place this after the combo. So I have this new data there, and then I do this. And what things do I need? So this guy, right? I mean this guy, yes. Okay, I need to change many things. Let's change the rarity. Dot rarity equals, so we're there, rarity. What else? Effect trigger event. What's this? Card moved, combo effect. Rarity. Item component. Combo component was this. Oh, because I have to create the component itself. So I configure the data and the component itself. So this holds the component. So let's first create the activation item component. Here, new data, item component. No, excuse me, item component equals activation trigger component. Great. So here I can do a, how was this? Target, combo effect, target type, slot. Oh, right. So with this I need these guys. Here, let me show you. The activation trigger type, the deactivation trigger type, and the activate while conditions flag. That's what I need. That's all I need. So activation trigger type. Is this public? Yes. Card trigger. Let's item card. Let's just copy and paste it. There. Brip. That's all I wanted. Perfect. Perfect. Oh, by the way, every time I finish something, I want to do this.
You win. Perfect.
There.
You win. Perfect. You win. Perfect.
That's what I want to do. Every time I successfully do something, I want to play that. was I? Not this. There. So with this I have a activation trigger, right? Yes. Equals the card trigger. So this is a card trigger. Activation. Let's do activation trigger. There. So the second is the activation trigger. Let's do this. The activation trigger. There. And then let's do a activate while. Activate. So this is what's condition flag. Condition flags. Activate while condition flags. Sure. There we go. What else do I need?
Perfect. Perfect. Perfect.
There. There. I don't want a rarity common. I want a rarity. So what else? Item component, this component. That's all, I guess. That's all I need. Combat enter, poison, fusion. Okay, trigger. Okay, so now I should show the description and the description. Effect item component, get text. Okay. Let's what's this? Charge. Oh. Let's get another example. Empty combo card. What? No. Empty the component. So that's the combo, copy combo, scriptable object. Oh, because it's the card itself. Get text. What's the text? What's the text? Where do I place the text? Oh, so this text comes from the item card component. And get text. So this is virtual combo item component. Get text. Combo item component. So how do I get the text of the effect item component? Get text. So it's always virtual, but it's virtual because I need I mean I I have many types of effects like this. See, sleep, poison, shield. So I have many types. That's why this is virtual. Combo component. So let's go back here. Should I do it here? So there, get text. Charge. Do I need a charge? No, because this only has trigger there. So it should show the trigger. Charge. Sheesh. This isn't charge at all. Chart text. So let's put the text when this is created there. So the text is this, is as I wrote here, fusion it to an item, blah 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 blah. Exactly like that. Fusion it this to an item, fusion this to an item to apply its activate it this new card, this its activation triggers, its activation trigger. What else? So trigger on exit combat there. So this should be colored. On exit combat, while poisoned, while confused, there. Trigger. Text plus text. Let's do a V break and then no string helper. This should be trigger. Color attention effects. So what's the color for trigger? Update there. Description, activation event, activation trigger string. So this should be trigger. Activation trigger there. So this is the color for trigger. Let's do this. Hex color trigger. There we go. String helper, where are you? There I need. Let's use this. event trigger string. Where are you used? Update card activation trigger type. Okay, this is going to be difficult. So I already have this, so I'm not going to use it again. I just need the trigger events. There. That's all I want. Text. What? Text. So this is your text. Get text, return text. Simple. To an item card to apply its activation trigger. That's all I need. That's all I need. I already have a function to display this. Okay, so this is finished. Therefore, I must play this.
Perfect.
There we go. So now I need to come back here. Okay, item component trigger. This is all finished, and then I add it. Okay, so I understand that.
Perfect.
All right, perfect. There we go. So now I can do a create new activation trigger data. There. Is that correct? Yes, it is. Rarity. So you are very rare. I think all of this should be very rare. So there, card trigger on enter close combat. Let's do on exit combat. Let's copy this on exit combat, on exit combat. And this is none, right? What? Condition flag? No condition flag. Okay, none. Okay, maybe I should. Is this correct? If I place a 0 here? There, 0. So this is very rare. And it's activated on exit combat. Let's create a new one. So this is triggered enter close combat. There, and it's triggered while in close combat. Enter close combat. There. So maybe I should have one that says the activation trigger and activation trigger, right? The activation, they're the same. Should I say on exit combat or not? Maybe it's too clumsy. On exit combat. Yes, all this is more likely an internal variable. So all of them will have this. Let's see, very rare. So this is activated when healed, when attacked. Each time it's attacked, it does something. I rather not. So this, let's say, while in close combat, there. There, so when this is healed, when this guy is healed, and the condition is it needs to be in close combat, or no condition. Actually, it keeps getting activated. No, it never keeps. It's only applied if it's sealed. Every time it's sealed, it does it. There. Or when attacked, why not? So every time he gets attacked, it does something. Why not? Attacked. There. So I have already 4 activation triggers. I need to make work. I need them to be able to work. So let's go here. So where is this visit? Attack card, item component, there. This is a combo. Permanent. All right, the permanent effect. So this is a item component type, activation, item component, break, oh, I need to set the item component card, combo condition. So I'm going to change this to trigger, right? Trigger. Activation trigger. There, or I already had this. I already had this there. Item component type, activation trigger. So let's add the card itself. Or not. empty combo cards there. So I have this. I need there an activation, empty, activation trigger, component SO. There, let's use this as the base, as the reference. Okay, this is the reference. Where it is? Okay, let's just copy all of that. There. So item component type SO. Item component type SO. My activation trigger. Component. SO. Let's do copy activation trigger. There. Okay, let's try again. My activation there. If that, no. Wait a second. Why do I have this? Oh, because it's the copy, right? Wait. There, so combo copy. Okay, so this copies it. My activation trigger copy. There, copy, 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 return copy. Let's delete this. There. Let's do my activation trigger, combo target type. There, combo effect, whatever. What's this? Combo? Oh. this. What? My activation. Combo item component. I see. Activation. Item component. So this is not the SO. It's the component. Their component. Activation trigger, activation trigger. So I need 3 of these. 1, 2, 3. Deactivation trigger, deactivation trigger. Active while, active while. There. Copy my activation trigger text. Actually, this isn't needed. Or maybe I should, just in case. What? No. Why did they write SO? Crazy. Okay, time for a coffee. I'll be right back. Okay, so I have this just in case. Let's go back here. There. This is a must. Paste. So there is actually really easy. But instead of their combo item component, what's this? Let's add one more, the activation trigger. Let's place it there. So where was I? There. So I don't think that's necessary. Wait a minute. Is this used somewhere? Component. Oh. Card brief. So yes. So let's this is actually very different. No copies, please. let's do a activation trigger. None. Item component card is O. So this is to create scriptable objects. Combo component SO. I don't actually use this. But it's there in case I need it. So let's just get rid of this. So then let's get this. Combo, instead of this I can do, let's get this. Item component, activation triggers. Without this. Activation trigger item component there. Let's change this. Activation trigger component. So I don't have values here. Activation trigger component. No need for this. Let's see. So this is what I use to get a shuffle bag. Activation tree indexes shuffle bag. Should I say int index? There. There. So then I copy it, I create a new copy of this. activation trigger. Activation trigger component. Okay, this isn't needed actually. There, I need 1, 2. Actually, only this one. Okay, let's get this. Components list. As item component. And then I do a copy. Activation. There, let's do a copy. Okay, this is easy. Return new. Okay. Let's do a copy. Public activation trigger. Copy. So write return new activation trigger component like this. There. So I have this dot activation. There we go. And text equals to this text. Actually, this isn't necessary. Or is it? Is it not? No, it's not. Because this caused this. So where was I? There. So let's do a copy. And there we go. Get random trigger equals activation night trigger component. So now I need to fill this activation trigger components indexes shuffle back. Okay. Okay, so there. Activation triggers shuffle backs. I just need the positive activation trigger where vase. So actually I don't need this because I don't have positive or negatives. Activation trigger there equals there. I have activation components data list. Okay, cannot convert. Can I set in? Can I say out? No. Okay, never mind. Let's do this. There, cast. There. So wait a second. How was it called? That thing where positive cast data to list. So this is a list. Activation trigger component data list. Base components. So why this doesn't work? Explain. What? But it is. Base variety item data. It is. Action trigger item component data. It is. It is a subclass. See? Class base variety 8. It is. See? Base. Yeah. Wait a second.
Take a look at this code. Looks harmless, right? We're assigning a list of enemy components, which clearly inherit from mono behavior, into a list of mono behavior. So why does this throw a compile error? A lot of devs assume this is a polymorphism issue. Maybe the types aren't compatible the way they think. But that's not what's going on. This isn't about class inheritance. It's about how the C# compiler treats generic types. Today we're going to break down 3 powerful and often misunderstood concepts in C# generics: invariance, covariance, and contravariance.
Let's ask, what about variance? Invariant by default, which means that a list is not considered to be a subtype of list, this even if is a subtype. This is because the type parameters of a generic type are not covariant, meaning that they do not preserve the subtype relationship. To enable variance, you can use the out keyword when declaring the type parameter of the generic interface, for example. Out. Okay, by using the out keyword, you are declaring that the type parameter t is covariant, meaning that a rarity shuffleback can be treated as an rarity. Okay, so this guy, you say this list is crazy. What's happening? Out. This doesn't work. What if I place in? Okay, let me check.
By the end,
Let's go.
and instead I'm going to make a
So
new
this
list
is
for all my bosses
invariant.
called damage all and pass in my list of bosses.
So
Just like before,
bosses,
C#
no.
refuses to treat a
Don't
list of boss as a list of enemy. This is still invariance. This is not about the values inside, it's about
invariant.
how the type system treats generic containers
Crazy.
like list of boss versus list of enemy. The vast majority of generic types in C# like list, dictionary, and hash set are invariant. That means you can't substitute one with another, even if their type arguments are related by inheritance.
Yes.
Invariant literally means cannot be varied. This means the type parameter is locked. You can't vary it. List of type boss is a different, unrelated type from list of type enemy, no matter what the inheritance hierarchy says.
Indeed.
Now, what if we make a small change to our parameter in the damage all method?
Yes.
I'm going to change this from list of type enemy
Out.
to I enumerable.
Oh, I enumerable. That's another solution. So there. Instead of a list, I enumerable. How dare you? So operator equals cannot be applied to operands count. Okay, so that fixes the issue. Check this out. There. Oh, there. Did you see? It's fixed. But what happens if I use a list? Oh, error. Because it's invariant. The list is invariant. See, the list is invariant. So if I use an I enumerable, what's this called? This is like it's an interface. Get enumerator. Get enumerator. Oh, so this is a there enumerable. Anyways, if I use an enumerable, so the enumerable is an interface. That's all. There. It's fixed. I don't need to convert it. Interesting, isn't it? That's because the list is invariable, right? Invariable? Invariance. It has invariance. Is cast. Covariant there. So now it's covariant interface. The I enumerable is covariant.
Of type enemy. Notice that immediately our compile error disappears.
Yes.
So what's going on? We're
It's
still passing in a
covariant.
list of boss,
This
and we're still
interface
treating
is
the elements
covariant.
as enemy, just like before. The difference is that IEnumerable is defined as covariant.
There.
This means it allows substitution of more specific types.
The covariance means we can substitute a more specific generic type where a more general type is expected, but only in a read-only context. So I can't modify this list.
Types like list of type boss when a more general type like IEnumerable enemy is expected, but only in a read-only context. IEnumerable T is read-only by design. There's no way to add, remove, or modify elements.
There is no way to add, remove, or what else?
There's no way to add, remove, or modify elements.
No way to add, remove, or modify elements. So that's the interface IEnumerable.
Let's open up the interfaces for IEnumerable and IEnumerator and take a look. In C#, covariance can only be applied to interfaces and delegates.
Okay, so covariance is for interfaces like this and delegates. Okay.
Notice that these two interface definitions include the out keyword. That out T means the type parameter T is only used in output positions, like the return values or properties you read from. It tells the compiler this type is safe to substitute with a more specific one because nothing is ever written into it, only read from it. That's why we can treat something like a list of boss as a more general type IEnumerable enemy, because we're just enumerating, not modifying.
We
can show that IEnumerable is read-only. Let's try a few common mutation operations. You can't add, you can't assign by index, and you can't clear. None of these work. That's because IEnumerable T doesn't define any way to modify the
there. So IEnumerable, this enemies list is an IEnumerable. So it's not really a list anymore. I can't add, I can't modify, and I can't clear it. But it's like a collection. A collection are, yes, like a group of things. A group of enemies.
Collection. Imagine if this method did IEnumerable T doesn't define any way to modify the collection. Imagine if this method did something like added a new enemy to the list. Now our list of boss would have something that isn't a boss.
So I could add another type of enemy that isn't a boss. But I defined bosses as a list of bosses, not any type of enemy. Correct? That's the key, I think. Because I could have, for example, NPC, right? NPC, I have bosses, I have main characters, I have heroes, I have vendors, and so on. So if the boss is an NPC, and I define the list of bosses as a list of NPCs, as a list of bosses, and I place this enemy is an NPC, there I could have vendors and heroes in the list of enemies if I could modify this. But this sets the collection so it can only be read, not added, not modified.
And that's exactly what makes it safe for covariance.
So
we can use the more general type because it's read-only. Now let's flip it. Contravariance is the inverse. It allows us to substitute a more general type when a value is only ever being passed in. While covariance is about pulling data out, contravariance is about pushing data in safely. Just like covariance, contravariance is only supported on interfaces and delegates. So for this example, let's make a new delegate handle target of type T. Now let's write a method in our class that matches this delegate signature. This method, handle enemy, takes in an enemy and just outputs something to the console. We can assign that method to a delegate instance that expects an enemy, which works just fine. But now watch what happens when we try to assign that to this same method, but using the type boss. It doesn't compile. Even though boss is an enemy, the delegate types aren't compatible because the delegates are invariant by default. And this is exactly the kind of situation where contravariance comes in. Contravariance allows you to substitute a more general type when a value is only used as input.
Allows a method or delegate to accept a more general type than originally specified as long as it's only used for input. So no reading, only modifying.
So how do we do that? Very similar to the use of the out keyword.
In.
Here we're going to use the in keyword. As soon as we add the in keyword to the delegate signature, the compiler error disappears because now the delegate is contravariant and the type substitution is allowed. Now that we've added the in keyword to our delegate, the compiler understands that it's safe to assign a handle target enemy to a handle target boss. So if I were to create a new game object with a boss component on it, I could change the boss's health to something different and run that boss handler, which is really an enemy handler, on the boss. It compiles fine. Now, using the in keyword says nothing about immutability. You're still allowed to modify the object you receive. So maybe in our handle enemy method, we might actually want to change the health of the enemy. This is perfectly valid, and it makes sense because boss inherits from enemy.
Yes.
So anything that can handle an enemy can safely handle a boss too.
Okay.
The compiler knows it's type safe to pass a boss into a method that expects an enemy.
Yes. So this handle delegate, let's see, where is this? Handle target. So this is a delegate, handle target. Where is the enemy handler? There. I have two delegates, right? Enemy handler and boss handler. So this boss handler uses the same as this enemy handler, and this enemy handler uses handle enemy, which is this method. Okay, so when I call boss handler, which uses this enemy, which takes an enemy, it says okay, good. By the way, it says void, right? It returns void. I can modify the properties of enemy.
However,
Great.
it's important to note C# still needs an explicit in keyword to allow that substitution.
There.
When I was a beginner, learning about variants and finally understanding why things like list boss aren't list enemy felt like overcoming this invisible wall in my understanding of C#. It made me feel more technically grounded, and suddenly I was writing APIs and systems that were not just working, but designed with intention and flexibility. Now let's look at how variance shows up in real architecture, not just in toy examples. Imagine you have multiple factories in your game, one that spawns enemies and another one for bosses. Both inherit from mono grounded and suddenly working, but
so in out, if this was out, I couldn't do this. I wouldn't be able to do this because out is just for reading. In is for modifying. So I can read it here, no problem. So what's the thing I cannot do with in, I wonder?
But designed with bosses. Both inherit from mono behavior, and you'd like to treat them polymorphically through a shared interface. Here's where covariance makes a real difference. We define a generic factory interface marked with out T because it only ever returns values. It never accepts them. Then we can have
it only returns values. It never accepts them. Okay, yes. So that's
T,
the first
because
example.
it only ever returns values. It never accepts them. Then we can have concrete implementations, one that produces an enemy and one that will produce a boss. Now here's the power of covariance. If I were to create another class here called enemy spawner, the enemy spawner could keep a reference to an ifactory of type enemy. Now in our start method, or perhaps using dependency injection or a service locator, I can assign an enemy factory into this reference, or I can assign a boss enemy factory. This is exactly the kind of small design choice that makes your systems more modular, more composable, and more future-proof, with the compiler helping you stay type safe. This is due to variance, not polymorphism. For example, if I were to remove the out keyword from my ifactory definition,
Nope.
immediately we see we have a compile error. The
Yes.
boss enemy factory is no longer assignable to our ifactory of type enemy because our ifactory has now become an invariant. If I restore the out keyword, but I try to add a method to my interface where I am actually taking in a type T as input, this violates the variance contract. If this was allowed, you would be able to pass in an enemy into a factory that only knows how to handle bosses, and you'd end up calling methods or accessing fields that don't exist. Because we've defined our interface as a covariant, we can't use type T in an input position. As soon as T flows in, the type can't be covariant anymore. Now let's look at another example using delegates where we take a closer look at in and out.
ifactory enemy. So there, create enemy, create a boss.
I've simplified our targeting system class, and I'm going to add a delegate similar to what we had before. I'm going to call it target handler. Let's make a few other classes.
Okay. I get it.
Perfect.
As we say, perfect. Great. There we go. So let's what? What amazing illustration, isn't it? It's awesome. Anyway. So I just made this work. I have the activation trigger components here, shuffle bag, and I have this get random item component activation trigger. So I have this shuffle bag functioning. Wait, do I? Sure, yes. I don't need to initialize it because the shuffle bag creator does it for me. So I have this guy, range, I have the index, I get the index and I copy it and I return this. So I have a component there. So there, activation trigger. With this, I have a component, item component. There, let's see, combo item component, combo item component, new, there. So with this container, combo item component, I replace it. What? Combo, wait, no. My item component container, activation trigger, activation trigger, no, get random activation trigger. This doesn't get a true activation trigger item component. So with this new, let's just remove this, the activation there, activation trigger event there. That's actually all I need. So let's do this, deactivation, activate while, there, that's all it does. There, my component, there, perfect. String convert, boom. Attacked. Exit combat. There. Exit combat. Let's do healed. There, how many do I have? For enter range combat, exit, enter close combat, attacked. Good. Okay, so okay. Activation trigger. Okay, let's create a new one. Activation trigger card to player. That's a activate trigger card to the player deck. There. Add activation trigger cards. I need a card activation trigger. So I need a card. combo card. I need to do the graphic. Ping, 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 ping. Scriptable. Activation trigger, item component, activation trigger component, assets, cards, playable items, components, activation trigger, there. So this empty activation trigger card. There we go. What's this? Item component type SO. My activation trigger component. Fusion this to an item card to apply so empty combo card, item component card SO, item component type O, item component card SO. That's the mistake. Title activation trigger, apply, okay, fusion it there, fusion it to an item card to apply this activation trigger, apply. Apply. So let's do this activation trigger. Let's add these two cards. Let's make this very rare, and let's make this ranged magic building close combat skill fusion activation trigger. Very well. Component card activation trigger. Activation trigger. So what? Activation trigger. Activation. Activation trigger cards. There we go. Let's change this. Activation. Cards. Animation. Okay, so let's see what this is. Fusion. There, fusion. Oh, I need a component. Item component cards. No, that's not what I wanted. Combo component SO. So I got this item component type SO. So again, I made mistake here. So this is all wrong. This is the component, not the card itself. This is the component. Component there. So this is item component cards. Let's see. Tools there. Item component cards. There. Item component cards. Assets. Cards. Playable. Items. Components. There. So this is called an empty activation trigger card. Thank you. So how are you called? The activation trigger. Title. Let's modify this. Alright, rather they're simple. Very common, no, very rare. This is a fusion type. There I copy paste this here. Activation trigger. Combo. There we go. So as you can see, it's basically the same. I only need to make this unaddressable, placed on cards, and set this as card data. There we go. Activation trigger, empty combo component, Activation trigger, fusion, common, very rare, very rare. There we go. So with this, I should have an activation that can be applied to an item. So I'm expecting bugs, but let's see. Add activation trigger card to player. Okay, add activation trigger card to player. Let's see. Okay, cover your face because this is going to blow up. Blow up. Okay, as I said, this equals 0. Wait, let's recompile. Be right back. Let's see why there was an error on the count. Why I can't have a count? Just count. Value cannot be null. What? Shuffle back rarity. Source. Let's see. 4 activation trigger list. Oh, I forgot to actually create such a list. There we go. That was the problem. Okay, maybe I should set this in debug mode. So it's faster.